Hello, this is section 1.4, building functions from functions. The first idea we're going to talk about is arithmetic with functions. So honestly, what arithmetic with functions is saying is adding, subtracting, multiplying, and dividing functions. So for this one, I'm actually going to do a quick example because it is relatively easy. We've got two functions here. We've got f of x is equal to 2x minus 3, and we've got g of x is equal to x squared plus 1. So we could be asked to find f plus g of x, which is really the same as f of x plus g of x, and it's literally adding the two functions. So I'm going to take my f of x function, which is the 2x minus 3, and I'm going to add to it. So that was my f of x function, my g of x function, which is x squared plus 1. And of course, we're really smart students, so we would not keep it like that, right? We would make it x squared plus 2x minus 2. This is these two functions added together. The difference would be the same. Of course, the only thing we have to be careful of is the order, right? F minus g of x is f of x minus g of x. And be sure you are putting parentheses around things. So f of x is 2x minus 3 minus the g of x function, which is x squared plus 1. And be careful because technically we are distributing that negative to both. So 2x minus 3 minus x squared minus 1, which would really be negative x squared plus 2x minus 4. If we want to find the product, they could ask you for f times g of x, which really is the first function times the second function. So in our case, f of x is the 2x minus 3 times g of x, which is x squared plus 1. If I want to multiply this out, I am going to FOIL. So first 2x cubed outside plus 2x inside minus 3x squared, and last minus 3. And then again, we're going to make this look nicer because we're really smart. We would write it in descending order. So 2x cubed minus 3x squared plus 2x minus 3. If I had been asked to find g times f of x, because multiplication is commutative, I would have gotten the same answer. Last but not least, quotient, so division. They could say either f divided by g of x, which would be f of x divided by g of x, or of course they could do the other, right? G of x divided by f of x. Order is important here. So in this case, f of x is 2x minus 3, g of x is x squared plus 1, and honestly, that's all we can do. We don't need to do anything else because we can't simplify that fraction. This is our new function. Again, the title of this section was building functions from functions. We just created a bunch of new functions here. Oh, sorry, that was bad. We just created a bunch of new functions here by adding or subtracting, multiplying or dividing. The second piece of this is composing functions, meaning, to compose functions is the verb. So compositions of functions is another thing we could do. This looks like FOG of x. It looks like fog, but I promise you it's not. What this is saying is f composed with g of x, meaning I am taking my g of x function and plugging it into my f of x function. This is an open circle. It's not like a multiplication mark, which would just be a dot. And if it was, of course, g o f of x, this is g composed with f of x. Notice the order from left to right is what we are doing from left to right here. We are going to do an example of this in class. So get excited for that. The other thing we have to talk about, though, is domain of these functions. So, and this is another thing that we're going to go through mostly in class, but I will give you a little bit of information now. The domain of a composition, the domain of a composition of functions so like f composed with g of x, that's what we're looking at, will consist of all x values, will consist of all x values in the domain of g of x, in the domain of g of x, that map to a value, that map to a value in f. So we are going to look at this together in class, but I just wanted to give you some of that information right off the bat. And then last but not least, we're going to talk about implicitly defined functions. So implicitly defined functions, well, there are some, we've looked at the idea of a function, right? A function is each x has only one y value. But of course, there are some things like a circle, for example, x squared plus y squared is equal to 4, let's say. That would look like this. Oop, I don't want yellow. Here's a circle. It has a radius of 2, centered at the origin. So this is a circle which has this equation, and obviously that is not a function, right? If we did the vertical line test, it would not pass. So what we can do is define this in two different ways. If I solve for y, I'm going to have 4 minus x squared. Y is equal to, if I take the square root, technically positive or negative square root of 4 minus x squared. And now I have two different equations. I have the positive version, which is technically the top half of my circle, and I have the negative version, which would be the bottom half of my circle. If you don't believe me, which it's fine, I guess, go to your calculator and type in y is equal to the square root of 4 minus x squared, and y is equal to negative square root of 4 minus x squared. You will see them graphed, and they will form a circle. Implicitly defined functions, or specifically, these two functions right here are implicitly defined by this guy up here. So we will look at another example in class, but an implicitly defined function is a function that basically we can't really look at on its own because it's not a function. So we have to break it up into two pieces. All right. I'm going to just do one tiny additional thing because this seems to be a problem sometimes. So it's just this it's with function notation. So let's say I had 4x cubed plus 2x, and that's my function, and I want to find f of 1. What this is asking us to do is take this 1 and plug it in for x, right? So this would be 4 times 1 cubed plus 2 times 1, which would really be 4 plus 1, which is 6. Now, it doesn't matter what I am asking you to plug in. If I have a function, I am literally taking that thing and plugging it in for x. So f of smiley face would be 4 times smiley face cubed plus 2 times smiley face, right? Or a more challenging one, if I wanted to find f of x plus 1, I am going to take that entire thing and plug it in for x in my original equation. So 4 times the quantity x plus 1 cubed plus 2 times the quantity x plus 1. So that was just a tiny little review on function notation, and I will talk to you guys in class. Have a great day.